My pleasure to introduce to you today's presenter, Kevin Schweers, and a little bit of background on Kevin. He's been an IT education instructor for over 15 years. He has over 35 years of computer networking experience. He currently holds the CCNA Routing and Switching and the CCNP Data Center certifications. And with that, Kevin, it's all yours. Take it away.
Okay, well, welcome. And I'm grateful for the opportunity to present this to you today. And what we're going to discuss is Ethernet LAN segmentation. And I'm going to refer to the OSI model. Some of you might have opinions that the OSI model is dead and antiquated. Interesting enough, I went to Cisco Live a few years ago, and I made it a point to go to every single vendor and ask them to describe their product. 100% refer to the OSI model. So I'm going to continue with this. Two primary terms that are phrases you need to invest in when we talk about Ethernet, because back in its inception, Ethernet was chaotic, that it was a shared medium. And so we have to identify collision, also known as contention domain, which has to do with when is it my turn to transmit. So the way Ethernet works is it will sample the media to see if there's currently something transmitted, and only if there's nothing will it transmit. For that reason, we could occasionally have collision from multiple devices listening at the same time, hearing nothing at the same time, and transmitting at the same time. So the protocol for bound media would be carrier sense multi-access with collision detection, and in unbound media it would be carrier sense multi-access with collision avoidance. The other term is broadcast domain. How far does the broadcast travel? At layer 2, that broadcast will be 12 hexadecimal Fs. So contention domain, also known as collision domain, compared to broadcast domain. I want to start with acknowledging the Ethernet frame, OSI layer 2. You have a preamble, which is for synchronization and timing. Directly behind the preamble is the destination MAC, excuse me, followed by the source MAC, followed by the type or length field, depending on your flavor of the frame, followed by data, and then a frame check sequence. If you add up the total bytes, we don't include the preamble, but you add 6 bytes for the destination, 6 for the source, 2 bytes for the TL field, and the lowest value of the data could be 46, followed by 4 bytes frame check sequence. We have 64 bytes, which is the smallest accepted Ethernet frame. If you receive a frame greater than, less than 64, we call it a runt, and that comes from collisions, like from a shared segment. The other extreme is 6 plus 6 plus 2 plus 1500 plus 4, giving us 1518, the largest accepted Ethernet frame. If we receive a frame greater than 1518, you'll commonly refer to it as a giant. If you're taking a Cisco CCNA test, they like to say that if it's from 1518 to 1600, it's a baby giant, because if one end of the segment is switch port mode access and the opposite end is switch port mode trunk, then the access side will give you a message talking about a baby giant. And then greater than 1600, we just say jumbo. All right, so the physical layer of the OSI model using Ethernet, there is no segmentation. We call it a flat network because regardless of the number of physical interfaces, they all share or participate in one common collision domain or one common broadcast domain. They're called repeaters, often referred to as hubs or non-intelligent hubs. The way they work is a frame is received, but then that frame is repeated out all ports, including the port in which it arrived. So this would help us get beyond our segment length. So 328 feet, and you might be familiar with the Ethernet rule, the 543 rule that says you can have 5 segments using 4 repeaters, but only 3 of those segments could be populated. Now we're going to move up to OSI layer 2. And the layer 2, you test takers, brings multiple smaller collision domains. That's what layer 2 does for us. Multiple smaller collision domains. Each physical interface is a unique collision domain, and we hope that you connect each physical interface to a single host so that you can enjoy the benefits of full duplex without collisions. Back in the early 90s, when we first introduced layer 2 devices, we had a bridge and you had coax cable with multiple hosts. And then later we went to a layer 2 switch. But even though we had a layer 2 switch, we would connect downstream from the switch to a layer 1 device because commonly you had a office space with a layer 1 device in the corner. And so that layer 1 device would connect to a centrally located switch in the closet. And therefore you still had a shared segment. We share, layer 2 performs segmentation on a hardware address. OSI doesn't know what a MAC address is, you test takers. So MAC address is simply an example of a hardware address. Now, also at layer 2, we can do VLANs. VLANs is the logically segmentation of a physical device. And they create multiple smaller broadcast domains at layer 2. At layer 2, giving us segmentation, security, and network flexibility that we enjoyed on a router. Without VLANs, you need to purchase a router. In the early 90s, routers weren't as common or frequent in your networks as they are today. We followed a rule called the 80-20 design. 80% of the time, source and destination are mathematically local. So back in the early 90s, it was switch when you can, route when you must. Today, we like to flip that to the 20-80 design, route when you can, switch when you must. So without VLANs, broadcast domains were simply controlled with a router. It's up to you, the administrator, to have knowledge of the VLANs on multiple layer 2 switches and then connect them in order to create one large broadcast domain. And we know that proper design dictates that if you have a unique broadcast domain, it should also contain a unique network address. And if that's the design, then frames from one broadcast domain should not reach another broadcast domain without a router. So going back to my Ethernet frame, you have your preamble. Directly after that, your very first 6 bytes is the destination MAC. And then your next 6 bytes is the source MAC. So as this frame is received by the layer 2 device, it says, do I own this destination MAC address? Because it could be personal to the device as a host, like CDP, STP, BDP, DTP, etc. This is at layer 2. All right, so if it does, it simply will then consult the destination IP because it might be telnet, ping, traceroute, etc. So this is when we're communicating to this device as a host. Management VLAN defines the VLAN in which the switch is accessible as a host, not to be confused with default VLAN. Default VLAN just means what VLAN exists out of the box and what ports belong to out of the box. Management VLAN is which one does the postal worker go home to at night so it can lick and stamp its own mail. So if the layer 2 device does not own the destination MAC, then it's work related. And it will learn the source. It will take the source MAC, stored in the MAC address table for 300 seconds, and then seeks the destination. Now, when at layer 2, we need an exact match, else flood. See, layer 2 can only flood, meaning I don't have knowledge, or filter, meaning I do have knowledge. The destination MAC, we said exact match. Well, that means all 48 bits, or you could say all 6 bytes, or you could say all 12 hexadecimal characters. Flood means I don't have a match, therefore I'm going to forward that frame out all ports except for the port in which the frame entered of the same VLAN. See, remember a VLAN behaves like a separate physical switch. So flooding and filtering is per VLAN. We will flood anytime there's a broadcast or multicast because they exist in the destination field only, and we learn from the source field. Filter means I do have an exact match, and I will intelligently forward that frame out that port only. Remember, layer 1 is non-intelligent, layer 2 is intelligent. Real world articles. Layer 1 is called a hub or non-intelligent hub. Layer 2 is called an intelligent hub, and layer 3 is an intelligent hub. But in Cisco's world, when you say hub, it's layer 1. So the original layer 2, as I mentioned, was a bridge. And back in this time, we used coax. So you had multiple sources per segment. So a bridge would learn the source, seek the destination, exact match, else flood. Whereas switches are behaving the same task, but they have multiple backplanes and they can maintain multiple unique conversations simultaneously. So let's look at an illustration of layer 2 receiving a frame. So here's my preamble with source and destination MAC. And this frame is going to be received in physical port 1, learn the source, seek the destination. Now, when we seek the destination, we're only going to consider the ports participating in the same VLAN in which the frame was received. So we're looking for an exact match in port 3, 5, and 7. We don't have a match, so therefore we're going to flood. The description of flood is to forward that frame out all ports of the same VLAN in which the frame arrived, but not the port in which it arrived. So we forwarded out 3, 5, and 7. So in my story, I just happen to have that destination on physical port 7. So now that's going to respond back. And again, learn the source, seek the destination. This time I have an exact match, so it will filter. Results in a filter. Your device can receive a frame and be programmed to make a forwarding decision at various steps. For instance, as soon as it finds the first destination, the first 6 bytes, the destination MAC, that's called cut through real time. And that's the Cisco default. The problem is that collisions can get forwarded. So the extreme opposite of that would be a storm forward, but now we add latency. So a compromise could be known as fragment free, modified cut through, or runt free, and that's where we read the first 64 bytes. That's layer 2. Now we're going to step it up to layer 3. These devices are called routers or layer 3 switches. Now, at layer 3, each physical interface is its own unique broadcast domain as well as collision domain. And we learned earlier that, or we agreed earlier, that a unique broadcast domain should contain a unique network. All right, so in this story, the router receives a frame, and like the switch, it looks at the destination MAC and says, is it for me? If not, I'm going to ignore it. When the router receives it, it's going to discard the layer 2. Then it's going to consult the destination IP. Do I own this? Because it might be host related, like telnet, ping, trace route, routing protocols, etc. If not, it will challenge the route table. It's going to challenge the route table for longest match, else discard. So unlike a layer 2 device where I can purchase, plug it in, and it starts by flooding and then eventually filters, a router is a brick until it has some information. So we take the destination IP, which is 32 bits long, and we know network's on the left. So we're going to look for a match of all 32 bits. If we don't have a match of 32 bits, let's look for a match of 31, if not 30, if not 29, 28, 27, etc. If there's no match whatsoever, discard. So what we'll do often is put a default route, a match of all zeros. And what that means, we're still following the exact match else discard. I'm sorry, longest match else discard, but the match is 0 says, if I know nothing, at least forward it to my neighbor. If I know nothing, at least forward it to my neighbor. All right. So that's the end of my presentation so far, and we're open for questions. I turn it back over to you.
Yep. Thanks, Kevin. Yep. I've got a couple questions here that I just want to go through. And again, anybody that has some questions, please do key them in at the Q&A side. And I guess this is just a review question. Can you go over the differences between a collision domain and a broadcast domain?
Okay, collision domain has to do with if I pick up my phone, is there a possibility that somebody else shares that same phone line? So if there's a possibility that my phone line is shared, when it comes time for me to access that phone, I need a set of rules that says, listen before you speak. And if nobody's talking, then you may speak. In the event that you attempt to speak at the same time as another and you have collisions, then hush up and for a random amount of time and reattempt. That's what the collision domain is about. It's about media access. Whereas a broadcast domain is, we know that a broadcast is 12 hexadecimal S in the destination field, and we never learn from the destination field. So every time I have a protocol like ARP or DHCP Discover that uses a broadcast in the layer 2 destination field, I know it's going to result in a flood. So the question is, how far does that flood go? Well, it floods throughout that broadcast domain, which terminates at layer 3. Was that a satisfying answer?
That's excellent. Thank you, Kevin. I got another question here, and this is one that's near and dear to my heart when I was going through the CCNA training. It says, what is an easy way to remember the OSI model 7 layers?
Well, if you Google it, there are many, and but the most popular is from the top to the bottom. All people seem to need data processing. So that's how you put it in order. Now, from the top, when your computer has deduced that So whatever you typed is going remote, it will enter the top of the OSI at the application layer, also associated with services, and then work its way down, just like when you address an envelope.
Okay, good. I've actually seen a couple of different examples of that, either top down, bottom up. And I'll tell you, Kevin, when I was doing, I just remembered PDN TSPA, and it just kind of stuck with me. So each person might have their own unique way of doing it, but definitely you have to know that and know it's solid for your CCNA training. Okay, sure. I've got another one. Just looking for best practice for VLANs, and should I have all my traffic using VLAN 1?
No, all of your terrorists are familiar with default behaviors. So even though VLAN 1 is the default out of the box, it's highly suggested that you create additional VLANs, not only for your employees like engineering, accounting, what have you, but for management, for unused ports, for the receiving of untagged frames, right?
Mm-hmm. Yep, good. Okay, we've covered the questions so far. If more come in, we'll definitely do that. If you want to jump to the next slide. So basically, again, I put a couple of links in the chat area for reference, and I'm going to be speaking with those over the next couple of slides here. And Kevin, I want to thank you for the webinar today. If you want to learn more about this topic, we recommend you have a look at our Cisco CCNA training courses on our website. The links that are pertinent for that I actually put in the chat area there, and you can refer to those. What you can do is if you click on our globalknowledge.com and you do a search for CCNA, you'll get our landing page for that. You can actually, if you click on the link within that course webpage, and it says take our CCNA bootcamp assessment, you can click on it. You can actually go through a little bit of a challenge, basically see if you're ready for the CCNA class or not. Okay. There's the other option that you do have is if you feel you're not quite ready for CCNA, we do offer something called the Cisco Enterprise Networking Foundations. And again, I put the link for that in the chat area. You want to look at that and reference it. And this is a course that's recommended for those pursuing their Cisco Certified Technician certification. It's the CCT on routing and switching. And it's ideal for those wanting to prepare themselves for the new CCNA course and cert, who may be newer to the industry. Okay. And next page there, Kevin. And as an attendee today, we've got we've got a couple of discount coupon codes for you. And we'd like to make it easy for you to get to take the next steps with us. Use the discount codes and receive 25% off your Global Knowledge course. You use Webinar 25 in the US and CA Webinar 25 in Canada. And next slide there, Kevin. And finally, be sure to visit globalknowledge.com website to access additional free resources like technical articles, white papers, and webinars. I will do one quick last check of the Q&A section, and it looks like we're good. Kevin, I would like to thank everybody for joining today. Good luck with your studies and have a great rest of the day. Thank you, everyone.
Once again, thank you all for allowing me to present this to you today, and y'all enjoy the rest of your day.
Thank you. Thank you, Will.